Question 12 is a probability tree diagram, but they've made it slightly more complicated because they've introduced algebra into it. So you have to really have an understanding of probability tree diagrams here to be successful in this question. So question 12, the probability that Rebecca will win any game of snooker is P. She plays 2 games of snooker. There's her first game, there's her second game. Complete in terms of P the probability tree diagram. So they don't want numbers here. We do not have any numbers assigned to any of these probabilities. We just know that the chance of her winning is P. So you can see here in her first game, the chance of her winning is P. That means the chance of her not winning is 1 take away P. And I'm going to just put that in a bracket so that my 1 and my minus P don't become separated. Now it's the same in her second game. She's got a P chance of winning and a 1 minus P chance of losing. P chance of winning, 1 minus P chance of losing. That's worth 2 marks. You get 1 mark for 1 minus P seen, and then you get the second mark for getting all the values correct. Part B wants you to write down an expression in terms of P, so again algebra, for the probability that Rebecca will win both games. So we're looking for the probability of a win and a win. So probability of win and win. So whenever you've got a probability that's an and, it means multiply. So I want P times by P. And you can leave it as P times by P, or you can have it as P squared. It doesn't ask you to write it in its simplest form, which is why you are allowed to keep it as P times P. Part C wants us to write down an expression in terms of P for the probability that Rebecca will win exactly one of the games. So I'm interested in the probability that Rebecca wins and loses, or loses and wins. So making sure I'm dealing with my signs correctly here. Let's do this one first. The ands are multiplications, and or means plus. So I need to multiply win by lose. So she wins, which is P, times by a lose, which is 1 minus P. Add a lose, which is 1 minus P, times by a win, which is P. And again, for this, they don't ask you for this in its simplest form. If they did, you could expand the brackets out if you wanted, and in the end, you'd come up with 2P minus 2P squared, or 2 times P times 1 minus P in brackets. There's all different ways, but they don't ask for it, so that is enough to get you the 2 marks. So and means times, or means add. Question 13 is a histograms question, but again, it's slightly more complicated than your usual let's draw a histogram. Remember, histogram is all about area. It's all about the area of the bars, not just the height. So the histogram gives information about the areas of 285 farms. So there's the histogram. They want us to work out an estimate for the number of these farms with an area greater than 38 hectares. So here's the area in hectares of the farm, and here is the frequency density, which has been left blank, which makes our life just a little bit trickier. So we're going to deal with that part afterwards. What I need to do is work out some kind of a key or a scale for this histogram. And to do that, I need to find the areas of all of these bars. Because whatever the area of all of those bars are equal to, they're going to represent 285 farms. So I'm going to want to find the area of all of those bars, and then that gives me what the that is equal to 285 farms. So let's start with this. In order to find the area of this bar, I need to assume some kind of axis for my frequency density here. Now, I want to find out what each tiny little square is worth. So in order to do that, I'm going to find the area of my bar in tiny little squares. So in order to do that, it's length times width or base times height or whatever you want to say. But I've got 15 along the bottom here. So 15 tiny little squares. And up the side, I've got 5, 10. And in fact, I'll label this up. Up to there is 10, 15, 20, 25, 30, 35, 40. So here I can see it goes up to 35. So it's got a height of 35. So the area of this is going to be 15 times by the height of 35. And that's going to give me an area of 525. Now let's find the area of this bar. It's got a width of 5 and it goes up 4.9. So, 49. So I do 5 times 49 equals 245. For this one, we've got a width of 10 and it goes up to 25, 26, 27, 28. So 10 by 28 is 280. Here we've got a width of 10 and it goes up to 25. So 10 times 25, which is 250. And finally, I've got a width of 5, 10, 15, 20, 25. And it's got a height of 5. So 5 times 25 equals 125. So that's the areas of those bars. Now, if I was to total those, I can find out what the total area of the bars are. So I'm going to do 525 and 245 and 280 and 250 and 125. Now, when I've added those together, it gives me 1,425. So I know that the 285 hectares is represented on my graph by 1,425 little squares. So in order to find out what one little square is, I need to do the 285 hectares divided between the number of little squares I've got, and that equals 0.2. And what that is each little square is equal to 0.2 hectares. So each little square is equal to 0.2 hectares. Now I can work on the question. So work out an estimate for the number of these farms with an area greater than 38 hectares. So hectares, 38. I'm interested in the area of this piece of bar and this whole bar and that whole bar. So in order to do that, I can see here I've got a width of 2 and it's got a height of 25, 26, 27, 28. So 2 times 28, which means this has an area of 56. So that little one there has an area of 56. And then for this one, I know it's 250. For that one, I know it's 125 because nothing else has changed. So what I need to do then is show 56 and the 250 and the 125. And when I add those together, I get 431. So in order then to find out what that is in hectares, I do 431 times by my 0.2, and that gives me 86.2. So yeah, the fact that they wanted an estimate for the number of farms with a greater area than 38 hectares, you can't get 86.2 of a farm, so it would be 86 or 87 farms, whichever. They will accept 86.2, but just remember we are talking about a number of farms, so a whole number is really required. Now, with regards to mark schemes, there's a lot of different ways of arriving at the correct answer for this. I'm just going to go through the method I've used. So you get 1 mark, it's a 3-mark question, you get 1 mark for an attempt to relate the areas to the total. Okay, so that statement is worth 1 mark. You can use all different kinds of scales. You can use 1, 2, 3, 4, anything. All right, but you get 1 mark for relating it to the actual number of hectares on the farm. You then get a 2nd mark for showing that you've added together the relevant bars. So you've understood the fact that you're looking at anything that's above 38 and adding whatever values you think those bars are worth, adding them together and then multiplying by your scale factor. That gets you the 2nd mark. And the final answer mark is going to be for getting the answer correct. Tricky question. Question 14 is a probability question, but again, slightly more complicated. Here are some cards. Each card has a letter on it. Rachel takes at random 2 of these cards. Work out the probability that there are different letters on the 2 cards. So first of all, let's look at what probabilities we're dealing with here. We can have the probability of getting an A, which is 1, 2, 3 out of 6. I've also got the probability of getting a B, which is 2 out of 6. The probability of getting a C, which is 1 out of 6. So that's assuming that there's only 1 card involved here. That's the probability of me getting those cards. However, she's taken 2 cards. So when she picks 1 up, there's only going to be 5 cards left. So that is going to be my first card. So there'll be a first card, which will be out of 6. And then there'll be a second card, which will be out of 5. So let me think of the different possible combinations now. What could happen is Rachel could find an A and then a B. They're 2 different cards. Or we would be interested in the probability of Rachel getting an A and then a C. Or we would be interested in the probability of Rachel getting a B and a C. So they're all the possible combinations: AB, AC, BC. Now, when you think about it, she hasn't only got the probabilities of that happening as it's written, because she could get an A and a B, or she could get a B and then an A. So each of these we're going to have to double at the end so that we include probability of B and A, C and A, C and B. But let's deal with this for now. We know ORs are adds and is times. So let's look at the first one, the probability of getting an A. So I've turned it over, first card, I had a 3 in 6 chance of getting an A. Times by my probability now of getting a B. There's only 5 cards left and both B's are still there. So it's 3 over 6 times by 2 over 5. Now for this one, the probability of me getting an A was 3 over 6. Times by the probability of getting a C. Now there's only 5 cards left. One of them are a C. Then there's the option of me turning over a B, and the probability of that happening was 2 over 6. And then I've only got 5 cards left to turn over a C. It would be 1 over 5. So they're my probabilities of A and B, A and C, B and C. So let's work these out. 6 times 5, that's got a denominator of 30. 3 times 2 is 6. So that's 6 over 30 plus 3 over 30 plus 2 over 30 gives me 9, 11 over 30. So I've got an 11 in 30 chance of getting AB or AC or BC. But remember, if we consider the fact we could have BA, CA, CB, then I can have 2 lots of that. So it would actually be a probability of 22 out of 30 for those combinations to happen. So the probability that I might get different letters is 22 out of 30. You could simplify that as a fraction to 11 out of 15, but if you're not great with fractions, my advice would be to just leave it as 22 out of 30. It's a long mark scheme, as you can imagine, for this question. It's 2.5 pages, so I can't go through all the different possible combinations. You can ask a teacher, but you would get a method mark for showing your statements with the words or in there. Okay, so if instead of an add here you had the word or, then that would get you 1 mark. You'd also get a mark for showing that you understand. One of them is going to be out of 6, one of them is going to be out of 5. So that would give you 1 mark for using the word or. You'd get 1 mark for multiplying the denominators, which are different together. You'd get another method mark for adding them and working out the total, especially because I only did 1 lot of calculations, then doubled it, and then you get the answer mark for actually getting the answer correct. So remember, the answer is 22 out of 30. It doesn't matter about 11 out of 15.